Hello, geometry, continuing with proofs, and we are still in section 2.5, and this is day 3 of 2.5, and we're going to be looking at segment proofs in this lesson. So looking at number 1, we have the given information of AB being congruent to CD, and we are ultimately trying to prove that AC is congruent to BD. If they didn't already mark A, B, and CD congruent with the little tick marks, I would do that, but that was done for you. I am going to add a little note to myself just to visualize what's going on. Our ultimate goal is to show that that piece from A to C is congruent to the segment that starts at B and ends at D. So there's our game plan. We want to show that those are congruent. And with every proof, the first line is the easiest. We will simply write down the given information. Then number 2, we have taken that congruent statement and rewritten it as an equation with an equals sign, and that is your definition of congruent statements. And the importance in doing that is that if you think you're going to use substitution, which is incredibly common in proofs, you cannot do substitution as long as things are congruent. You must change it to equality to an equation before you can do substitution. So that's why we're including that step. Step BC equals BC, number 3. That is your reflexive property. And that kind of seems like an obvious statement. But the reason that's in there is because of step 4. In step 4, we have AB plus BC and BC plus CD. On the surface, I'm thinking segment addition postulate because that's kind of what they're doing. AB plus BC. That is kind of like the segment addition postulate, but the segment addition postulate would not end with BC plus CD. AB plus BC in the world of segment addition postulate would equal AC, and that's not what's written. So what we've done to get this step is we've simply taken steps 2 and 3. We have added those two together. AB plus BC is the same as CD plus BD, and that is your addition property of congruence, of equality, I mean. Then number 5, we're going to do the segment addition postulate. And here is where I'm going to do AB plus BC equals AC. So here we are doing segment addition postulate with that left side. We have then BC plus CD on step 6 equals BD. That is also the segment addition postulate. And so we're using segment addition postulate for those two pieces. Now we're almost done. And one of the good things about proofs is that you know what you're trying to accomplish in the end. We are trying to show that AC is congruent to BD. And right now, I can do some substitution. If I know that AC is equal to AB plus BC, if those are equal, then I can take this AC and I can plug it in the place of AB plus BC right here in step 4. And then right here, I have BC plus CD is BD. Well, if BD is equal to this, then I can take BD and I can put it in the place of BC plus CD right here. And that is substitution. And again, that's why we changed our congruence to equality. And so with substitution, I can now say that AC is equal to BD, not congruent, because substitution doesn't work with congruence, only equality. Then finally, we can take that statement and turn it into AC is congruent to BD with your definition of congruent segments. So there's your first proof with segments. And we're going to go through 6 of these. So number 2, another fill in the blank proof, which is kind of nice. Step number 1 is going to be the easiest. I'm just going to go ahead and show you that one's going to be the given information. All right, so the given information is that AD is equal to 2AB plus BC. Our ultimate goal is to show that AB, we want to show that AB is congruent to CD. That's what I want to show. And I'm just looking at those and I'm trying to think how that's going to happen, but I want to be aware of what my target is in the end. And so what I'm going to do first is they have a representation of AD, but it says AB plus AB, which is kind of weird. So what I want to do is I want to have a more traditional way of adding up pieces to get AD, and we're going to do the segment addition postulate on steroids. Typically, segment addition postulate has been just 2 pieces, like AB plus BC is AC, but you can add 3 of them, AB plus BC plus CD. Those 3 segments together do form the segment AD. And with substitution, if I know that AD is equal to all of this stuff, then I can take all of this stuff and I can, actually, I'm going to substitute the other way. if I know that AD is equal to 2AB plus BC, I can take 2AB plus BC and I can substitute that in for the AD here because they are equal to each other. And so now I have 2AB plus BC is equal to AB plus BC plus CD. Then they jump all the way down to AB is equal to CD. So now I have to look at step 3. How in the world did they take all of this and whittle it down to only AB equals CD? And it's a lot of subtraction. We have BC on each side, so I can subtract BC from both sides of the equation. And I have an AB. I have 2 on the left side, 1 on the right side, so I can subtract an AB. And when I do that, the BC subtract out. This AB subtracts out. 2AB minus AB is 1AB. And we're only left with the CD on the right side. And we accomplished all of that through the subtraction property of equality. And then finally, the simple step, I have AB equals CD. We're trying to show that AB is congruent to CD. So we can change that to congruence with your definition of congruence. Okay, looking at number 3 here, the given information is really just describing the diagram they give you. B is between A and D, and C is between A and D. So we have the points B and C that are both between points A and D along this line. I am ultimately trying to prove, and I'm going to kind of draw this out, that AB plus BD is equal to AC plus CD. Now, if you look at the diagram, that's a pretty obvious statement. This is not rocket science here that we're proving, but we can't just simply say, look at the picture. There's a little bit more to it. So let's go ahead and get this one squared away. So the given information, I'm going to break into 2 entries. B is between A and D, and C is between A and D. So I'm just copying my given information. You could put both of that as step 1 if you want to. Then I've got to find a way to construct this. I've got to create that statement with something that we know. We've got to build with facts or postulates or something like that that we know. And if you look at this, AB plus BD and AC plus CD, that looks a heck of a lot like the segment addition postulate. But if we're doing the segment addition postulate, it wouldn't finish like this. It would go through the step that AB plus BD is equal to the whole AD, and then AB plus AC plus CD would equal the entire AD as well. And so I'm going to do the segment addition postulate. And because I'm doing the segment addition postulate twice, I'm going to put both of those segment addition postulates in step number 3. So I'm putting both of those in step number 3. That's your segment addition postulate. If you want to break that down into step 3 and step 4, this is not like a written in stone process here. So that's fine. So we have the segment addition postulate, and then we're almost done. I see that AB plus BD is equal to AB plus BD equals AD. AC plus CD also equals AD. So if 2 things both equal AD, then those 2 things must be equal to each other. So AB plus BD is equal to AC plus CD, and I'm going to call that substitution. And the substitution that I'm seeing is that if AC plus CD equals AD, then I can substitute this sum for the AD right here. Any 2 things that are equal can be swapped in and out through any other equation. Remember, no substitution in equality or in congruence. But there's 3. That was a quick one. You could even have done that in 3 steps. You could have combined steps 1 and 2 since those are both given. Step 3 is all segment addition postulate and then substitution. All right, looking at number 4, another one that we are building from scratch. They tell us that B is the midpoint of AC. So I'm looking at AC. If B is the midpoint, I'm going to go ahead and make a note to myself, those must be congruent. And that's kind of just my thought process of trying to get things going. I'm ultimately trying to show that AB plus CD, so AB plus CD is equal to BD. Wow. So that's like they've separated out the segment addition postulate. It's not truly the segment addition postulate in the end, although it looks like it. So let's see what we're going to do with this. I'm going to start with the obvious. Let's write the given information that B is the midpoint of AC. Now, I immediately, in my little diagram here, I marked AB and BC congruent. Well, that's really my next step in the proof. How did I know that AB and BC are congruent, which is a true statement? AB is indeed congruent to BC. Well, I knew that because I know what a midpoint is. I know the definition of a midpoint. Therefore, I can conclude that AB and BC are congruent. And then my very next step is to set those equal to each other because I most likely will be using substitution. So I'm going to go ahead and change that congruence statement into a statement of equality with my definition of congruent segments. And now I'm going to try to figure out how I'm going to get AB plus CD to equal BD. Now, since I'm trying to achieve BD, that's the right end of my equation, I really want BD, I'm going to go with a segment addition postulate that would give me BD. And the segment addition postulate that gives me BD is that BC plus CD. If I add those two segments together, it will give me the entire segment of BD. So BC plus CD does equal BD, and that is your segment addition postulate. And then we are one step away. And again, the good thing about proofs is we know what we're shooting for. We want AB plus CD to equal BD. We almost have that. We have the CD, we have the BD, but we don't have an AB. But since I know that AB and BC are equal to each other, then I can substitute this AB for that BC. And when I make that substitution, I have my objective that AB plus CD does equal BD. So substitution property of equality to wrap that one up. Let's go on and look at number 5. This one is a fill in the blank one. We have DW is congruent to ON. And so I'm looking here and I may just make a note to myself. I know, and this is not really mathematical here. I'm just making a note that that is congruent to that. And I may even put a little congruent mark there just to show what I'm talking about. And that's what I call math doodling. I'm just writing stuff down because I can. I am shooting to prove that DO, I want this one to be congruent to this one. And so that's what we're trying to show, that those are indeed congruent. So trying to wrap my head around this process or this problem. And so number 1, first step, shocker, given. And number 2, this is going to be something that we're going to almost do automatically. If we have a congruence statement of just two things like this, we will almost always go straight to saying that they are equal with the definition of congruence. And again, that is to open the door for substitution. We do not substitute with congruence. Then I have DO plus OW, DO plus OW, DO plus OW is DW. That is your segment addition postulate. And then they want us to use segment addition postulate again, and that would be with OW plus WN. So OW plus WN is also the segment addition postulate. Then they jump to DO plus OW is equal to OW plus WN. And we can make this leap in one step from 4 to 5. When I first looked at this problem, I was thinking I kind of wanted to put a step between 4 and 5. And you can. There are other ways that you can generate this proof. So if you do these and they end up being a little bit longer, that's fine as long as you're mathematically correct. Sometimes you can even make them shorter than the teacher does, and that's fine as well as long as you're following a logical flow. This one is going to be substitution, and here's my substitution. I know that OW plus WN is equal to ON, so I can take OW plus WN and I can substitute it for that ON. I also know that DO plus OW equals DW. Well, if DO plus OW is the same as DW, then I can substitute it in for the DW in step 2. And when I make those substitutions, I end up with DO plus OW is equal to OW plus WN. And that was a method of substitution. So we substituted. Then I am shooting for DO congruent to WN. And if I can get rid of those OWs, I will accomplish that. And I can get rid of them by subtracting them out of the equation. So if I subtract OW right here, so now I am subtracting OW from both sides of the equation. That will leave me with DO and WN. And then finally, we do not want equals, we want congruence. So we will use the definition of congruence to make our final statement. There is our Number 5, and last one. Last one is a long one, and we are constructing this one from scratch and looking at the given information. So I'm just going to make some notes to myself. It is given that AB is congruent to CD, and it is given that BC is congruent to DE. Now, I did a double take on this. When I worked this problem the first time, I went back and did a double take because if I'm looking at this, AB does not look the same length as CD. And if you got a ruler, they would not be the same. But if they tell you they are congruent, then you have to accept that, even if it does not look so. So AB is congruent to CD, BC is congruent to DE. I am ultimately trying to prove that AC is congruent to CE. I want to show that. So I'm just going to put 3 marks there because that's what I'm shooting for. I'll put a question mark because we don't know that yet. We're trying to prove that, but that's my objective. So starting our proof, step 1, the easy, write down the given information. And then step 2 is where I'm going to start thinking about how I can get to AC equals CE or is congruent to CE. So I've got to use some statement to get AC into the proof, and I could do segment addition postulate. If I take AB plus BC, that will give me AC, and I want AC somewhere in my work because that's what I'm trying to prove. And similarly, I can add CD and DE to get CE. Since both of those are the segment addition postulate, I'm just going to put them both in step 1, but I'm adding those to create my AC and CE. Now, I'm going to need to do some type of substitution to, I don't know, we're going to have to figure out how to get AC and CE to be the same. And to do that, I need AC and CE to equal the same thing over here. Right now, they don't equal the same thing. One is AB plus BC, the other is CD plus DE. I've got to turn those, use substitution to make those the same thing. And if I'm going to do substitution, we have to have equality. And so I'm going to take my given information and I'm going to change that given information to AB equals CD and BC equals DE. And honestly, I'm surprised I did not do that in step 2. I probably should have because that's kind of what we've been doing. That would have been consistent with the previous problems, but it doesn't really matter as long as you do establish that those are equal at some point. And if you establish those are equal at some point, then I can use substitution. And so now that I've declared those equal, I am free to swap AB and CD in and out for each other. Similarly, I can swap BC and DE in and out for each other. And I'm looking up here and I have those. So I want to do some type of substitution so that AC and CE both have the exact same thing on the left side. So what I'm going to do is this. If AB and CD are the same, then I can take CD and I can replace the AB up here with the CD. If I know that BC is equal to DE. If I know BC is equal to DE, well, then I can take BC and I can substitute it in the place of DE. And I hope that's what I did. I forgot what I wrote on my next line. I should have looked at this before I did this. And when I make that substitution, I'll have CD plus BC. When I make the substitution here, I'll have CD plus BC. And something tells me I did it the opposite way. So I may erase that. And no, that is what I did. Good. Okay. And so now when I make those substitutions, I have CD plus BC equals AC. I have CD plus BC equals CE. And since now AC and CE both equal the same thing, by the way, that was substitution on step 4, I can now set AC equal to CE. And that is again substitution because they equal the same thing. I'm basically taking the AC, and since AC is equal to CD plus BC, I can replace CD plus BC with the AC. And the final step, property of congruence or definition of congruence, I can say that AC is congruent to CE, and I should have segment bars above that. I forgot to write those in. There we go. So there's our proof for number 6, and that is the last one. I do want to explain my hesitation. When I went from step 3 to step 4, I was curious if I had done something different. You could have, from step 3 to step 4, you could have actually substituted this AB. I'll go to the highlighter. You could have taken this AB right here and substituted it for CD here. and you could have taken this DE right here and substituted it for BC right here. And you would have ended up with AB plus DE for both of those rather than CD plus BC. So there are always, almost always, going to be other approaches that are very similar but different enough that you may question whether or not what you did is okay. And there's a good chance that you are fine with your proof, even if it does not match exactly what we did. And that is it. So hopefully that makes some sense. Yesterday, y'all said that things were pretty easy after the video. Hopefully we haven't changed that. And good luck on the homework sheet.